Probability in finite sample spaces. The probability of an event E in a finite sample space S whose outcomes have equal likelihood is given by the formula below. If we have this type of sample space, it's referred to as a uniform probability distribution. All of the outcomes have an equal likelihood, and that's the very definition of a uniform probability distribution. In this case, the probability of the event E is equal to the number of elements in event E divided by the number of elements in the sample space, which can also be written as mod E over mod S. So let's look at an example of that. So if we take our sample space once again to be the results from a standard fair cubical die, so the numbers 1 to 6, and we have a couple of events in here, let's call them A and B. And let's suppose 1 is in here, 2 is in here, 3 and 4 are in here, and 5 and 6 are out here. The probability of event A occurring, so there's 2 elements we can see within A, so that's 2 out of 6. There's 6 elements in S, or 1/3. The probability of B occurring, now if we look at B, there's 3 elements in there, so that's 3 out of 6, so that's going to be a half. The probability of A intersection B, well, there's just 1 element in there, so that's 1 out of 6, and A union B, and you have to be careful, only count the 2 once, so that's 1, 2, 3, 4 elements out of 6, so that gives us 2/3, and clearly there's other things we can do, such as not A and not B, and so on. Now, some points to remember. An impossible event has a probability of 0. That's part of our definition of probability. A certain event has the probability of 1. So it's certain that the outcome here would be within the sample space, which is why the probability of S is 1. For event A, the probability of its complement A dashed or A bar is given by the probability of A bar is equal to 1 take away the probability of A. Let's just clear that up so we can see that one. And we discussed that one in the previous lesson as well. The expected frequency of an event, if we do the experiment n times, is given by expected frequency is equal to probability times n. So what we're saying here, let's look at this one. A or B. Let's suppose that we roll the dice 600 times. If we want the expectation, or the number of times that we would expect A union B to occur, we just multiply by the probability of A union B. So that would give us 400 times that we would expect it to occur.